Assalamu alaikum warahmatullahi wabarakatuh. Hi dear ladies and gentlemen. Today we are going to solve together an example about CNC G-code programming for a milling example to cover a revision for the midterm. Here we have a complete example of milling problem that include 3 steps. First step is to profile the outer profile, and the second is to machine the 2 internal indicated slots here, and last one is to drill 2 sets of hole. First of all, in this problem, as we have 3 different cutting tool for each machining operation, so we have to construct a tool offset table to use the definition of each tool in the required operation. The data will be included in the tool table is as follow. Let's construct here a table here. Here is tool number and its diameter, length, and the required offset. First tool as usual will be T01, second tool T02, and last one is T03. Here the diameter of first tool is 20 millimeter, the diameter of second tool is 40 millimeters, and the diameter of the last tool twisted drill is 32 millimeters. The length of the first tool is 100 millimeters, and second is 90 millimeter, and last is 120 millimeter. Here at H1 is a reference tool that used in setting the floating 0 indicated here in the problem, so H1 will equal 0. H2 is the difference between the length of first tool and second tool. The reference one is the first tool, so it will be negative 10 millimeters, negative 10 millimeters, and the last one is also calculated with respect to the first one, so here 120 minus 100 will be 20 millimeter. The first machining step is to mill the outer profile at the full depth, and here the full depth is indicated as 15 millimeter thickness, and the cutting parameters are S2000 and F19 for all operations. And to mill the outer profile starting from the starting point here in clockwise direction using automatic cutter compensation, and here in this example for midterm we will not use the cutter radius compensation, so this part is not included in the solving. We will solve the outer profile milling without radius compensation. Here to start the machining operation for this outer profile, starting from the start point in clockwise direction, so it will be in this direction. The machining of the profile will start at point 1, then point 2 using the arc 2.3, arc 2.4, arc 2.5, and 2.6, then finally 2.1 at the starting point once more. First, in the first block, you have to enter what we call a safety block, a set of G-code used traditionally in the starting of programming any part. G90 for absolute dimensioning, G17 for selecting XY at the cutting plane, G80 to close any opened cycle from any previous machining procedure, and G21 for millimeter dimensioning system, and G54 to indicate the floating 0, and G40 to cancel any to radius compensation, and J98 to set the default retract of the drilling if any drilling cycle were used before. After safety block, we have some parameters to identify here. We have speed of 2000 and feed of 19. Then we have a tool to mount. We are in the first cutting sequence, so the first tool is T1, so it's here 4 T01, and mounting the tool using tool change command M06. Setting the tool offset, we can set the tool offset in the same block using G43 with offset value of H1 in the same block. Then we can turn on the spindle using M03 as we identify both of speed and feed. Here the machine is ready and the speed and feed are identified. The tool and tool offsets are identified too, so we can start the cutting. And here, as indicated from the problem, the cutting is at the full depth of the workpiece, so the depth will be 50 millimeter. Here we can start the motion to go just above point 1 at the starting point. The coordinate of point 1 is 0x and 50 y, so we use D0 or 00 to x0 and y50 at a clearance distance of z, for example 10 millimeter as a clearance distance above the workpiece. So now we will go with the defined feed using J01 to the specified depth z negative 50. So at these points we are at the point 1 at the full depth required at 50 millimeter inside the workpiece. So we will start the profile from this line in 8. We will move in G012, so we don't write G01. This will take us from this point to point 2, from point 1 to point 2 using G01. The only dimension will be changed is the y dimension. Here we have 250 and the radius is 170, so the difference between them, if we subtract 250 minus 170, we have y 80 millimeter, so we reach point 2. Here we will move in a clockwise direction to cut this third circular piece, so we use G02. We will reach x and y using I and j to identify the center point of the arc. From here we will move to here at point 3. At point 3 we will be at the same x0, so we may write x0 or we may not write any x, so this y will be 250, the height of the center, plus 170, so it's 40 to 420 y. From the starting point to the center we have a height of 170 in positive direction, in the vertical 170 70, so we may write 0 in the y, or we may not write y at all. Now we are at point 3, and it's required to machine the path from 3 to 4. So here is other line, and 10 we are using the same G02. We may not write it, as we are machining in clockwise direction from 3 to 4. From 3 to 4 we have to write x and y, I and j. X and y of 0.4 here, x of 0.4 is the same of y of 0.3, is 420, at y here is 0. From the starting point 3 we identify the center of the arc, here is negative 420 in j, and it's 0 in I, so we can erase the I. Now we are at point 4, and it's required to machine it in clockwise direction from 4 to 5, so here, and 11 the same in clockwise direction to x, y, I and j, and here we need to go to point 5 of x from here to here, 80 millimeters, and y is the same, 0, so we can neglect it. The starting point of this arc is 4, and the radius of this arc is 170 in negative direction of the x, so it's negative 170i, and we may delete the j. So now we are at 0.5, and it's required to go to 0.6 using linear interpolation, so it's G01 to the same y of 0 at x equal 50. Next line is to go back to the start point in 13 G01, and we will move to x and y of 0.1. X of 0.1 is 0, and y of 0.1 is 50. As we reach another time to point 1, we have to go out of workpiece in 14 using G01, or we may use G00 to the clearance level at Z10. At this point we can end the program, we can stop the spindle and start the next machining procedure. So we will stop the spindle using M05. We will not use M02 because we have another machining procedure to perform. So M02 we will not be used here, and we will continue in the next machining procedure. Now it's the turn of the second point, is to machine the internal slots, 2 slots actually, here a quarter of circles, one of radius 370 and the smaller one of radius 125. So we will start at the finishing point. Here we turned on the spindle, so we will take care of this point and turn it on once more. Here we will start at N, as we finished here at N15. We will start here at N16. Now we have to change the cutting tool. I think we are working at the same parameter of S2000 and feeds of 19. but we will change the tool to the second cutting tool, TO2, with H2 tool offset. Here we will change TO2 with M06 for tool change, as we need to set the offset of tool using G43 with H02. So now we have a new tool mounted with new tool offset identified, and we need to turn the spindle on using MO3, as we turn it off as the last step here using MO5. And it's required to machine these slots using a depth of 20 millimeter, not 50 millimeter as the last procedure. So we will go above the starting point. I suggest, as there's no any indication, we will start from this point, we may call it point A, to this point, we may call it point B, and after finishing this slot we will go here to point C to finish the last slots at point A, B, C, D. Okay, we will use D00 to go to point A. I think point A here is 370 in X, 0 in Y, so we'll go to X 370 and Y 0 on the clearance distance of Z of 10. So we are in air, so we are free to use G0. And now we have a turned on spindle, so we can cut using G01 and go to the required depth 20, negative 20 in Z. And now we are totally engaged here in the slot with the required tool TO2, and it's required to machine this path, so it's a counter clockwise direction milling here, counterclockwise G03 to point X and Y using center identification of I and J. These points have an X of 0 and Y of the same, the radius 370. The starting point was A, so the origin with respect to the starting point is negative 370 in X direction and 0 in Y direction, so we can neglect writing J. Next line will be, as we finished this slot, we will go to out of the workpiece using G00 to the clearance level of Z equals 0. After getting out the workpiece here at B, we will move in air to point C, so line 22 we will use 2G00 until reaching the point C of X and Y, and here we can see it's at X equal 0 and Y at the radius of 125. Now we need to go to the slot depth at Z equal to 20 to negative 20 and machine the curve or the circular path in clockwise direction up to point D using G02 to X and Y and I and J for center identification. The X and Y of point D will be, the X of point D will 1, 2, 5 and the Y of point D is 0. The center identification from C as a starting point in J or in Y direction in negative 1, 2, 5 and I in this case will be 0, so we can delete the I. Once more we have to go out of the workpiece using G00 to the clearance level of Z equal 10. As we may have a next machining operation, so we will just turn off the spindle without ending the program using M02. If we have one more machining operation, we will not use ME2. M02 will be used only at the last machining operation to end the program. Now we are going to the last machining step required is the drilling, so we will delete M02 as we have one more machining operation is to drill the two sets of through hole. Here through hole and thickness is 50 millimeters, so we will add the half the diameter of the 32 to the 50 millimeter to get the actual depth we require. So we will use the tool number 3 with tool offset H3. Here we will start as finished at N26. Here we will start at N27 by changing the tool using T03 with the tool changing command M06. The tool offset adjustment command is G43 using H03 as we do. So now we have the tool mounted with the required tool offset, and now we are going to turn on the spindle using M03. So now we need to use the polar coordinate to facilitate describing these holes, and we will use the subprogram to just program the coordinate for one time and call it once more in another location. So here we will write another program and we will address it as O0002, and in this program we write N01 and we will identify the coordinates what we will use here. So we will use the polar coordinate using G16. As we know, after identifying the polar coordinate, the x, y coordinates will be replaced by r theta coordinate. This is phi 120 millimeter, so the r will be 60 millimeter. So the first hole, if we consider this hole number 1, 2, 3, 4, 5, 6, 7, 8 hole. So the first hole here will be a coordinates of r of 60 millimeter and theta of 0. So we will drill using simple drilling cycle of G81 using x, y, z as follow. The x will be r of 60 millimeter, y is the theta 0 degree, and z will be the depth of, as we said before, the 50 millimeter of the thickness and the half the diameter 32, so we will go to z of 66 millimeter, negative 66 millimeter. So this is the coordinate of the first hole to drill. Now we need to repeat the drilling using the incremental coordinate, using the change of each hole only the theta, so it will be at the same x, the same r, and the theta will be changed from time to another using 45 degree. As we made the first hole, so it will be repeated 7 times using L7. Using this L7 will repeat all holes at R of 60 and depth of negative 66 will repeated 7 times, and the first one will drill the first hole. So after finishing this set, we will close the drilling cycle and the relative or the incremental coordinate using G90 and G80. And the last thing here in the subprogram is to back to Cartesian coordinate and M99 to end the subprogram and back again to the main program. From the main program, we need to call the subprogram 2 times. One time at this point to drill the first set of holes, and the second time to this point to drill the second set of holes. So before calling the subprogram, we will go to the clearance distance of Z axis and call this subprogram to perform. After calling this subprogram to perform the drilling of the hole, we need first to move this origin to this point, just to make the hole about the reference we use in subprogram. So we need to use G92 and move the origin using X, Y, Z. From this point, we need to use the origin to be on this point. So we will write here X 215 and Y will shift it by 0 and Z will shift it by 0. So now from this point we are here, this will be our coordinate system, so we can call the subprogram using M98 and our subprogram is called M0002, is O0002. Okay, now the main program will go to the subprogram and perform the machining operation according to what we wrote here. Then it will back here once more. Before doing anything, we have to set back the coordinate point to the main origin of the program. So we use G92 and make it once more back to the main origin of the program. We need to transform our origin point to this point to call the subprogram once more to perform the drilling of this set of holes. So we need to write N33 and move the origin from this point to X0, Y 250, Z0. For all cases Z is equal 0, so we can neglect writing the Z at all. Okay, now we can call the subprogram once more using the same commands we used here. From this line in 34, the subprogram will be machined once more, but with respect to this point. We can delete both of this zero shifting line and use a zero shifting line just once from this point to this point. So we can highlight it here. We can remove this line. Now our 0 is here. I need to shift the 0 point to here, so we have to move negative 2050 in x, positive 2050 in y, so negative 2050 in x and 2050. So we can shift the 0 one time from this point to this point, just to highlight this line. Okay, after finishing the drilling of both sets of holes, now we can turn off the spindle, and we can also end the program, and finally we can end the tape. Thank you very much, ladies and gentlemen, and looking forward for seeing your wonderful answer on midterm exam, and good luck, do your best, and assalamu alaikum wa rahmatullahi wa barakatuh.